Hi guys, Miss Monserrati here with your math for today, Friday, February 26th. Alright, here we go. We are doing Lesson 4, still Chapter 9. It's called Hands-On. Use models to add unlike fractions. Yay, we're getting to unlike fractions. How exciting. Page 631, we're going to go all the way through the homework, page 636. So get ready, get a pencil. I know I'm using a pen, but I just use a pen because it's easier for you guys to see. I would always use a pencil for math. So you can use a pencil, or I really like these little mechanical pencils. They sell them at the dollar store even. Alright, so here we go. We're using models. So hopefully you guys remember these little models we used to use in school. Right? You guys are supposed to get some of these sent home to you, but maybe they'll come soon. I don't know. Anyway, so they just drew little pictures of them for us. So, unlike, or maybe you guys have some of these at home. I don't know. Maybe some of you have them still from last year. You got them in 4th grade. Let me know. Let me know in the comments. No, I'm just kidding. Unlike fractions, like I watch too many YouTubes, unlike fractions have different denominators, right? So remember what a fraction is, right? It's just, it's a number. It has a denominator and it has a numerator. I know those words sound a lot alike, so I try to remember how can you think of which way they go, which one's on top, which one's on bottom. So I just think D means down. It's the one on the bottom, right? Put a box. It looked like I was. Anyway, this D is the down one, right? Whoop. It's the one on the bottom. All right. So before you can add unlike fractions, one or both of the fractions must be renamed, change the number, the denominator, so that they have a common denominator, right? I have to change the denominator and the numerator, but I have to change the denominator so they're the same before I can add them together. So, to finish building a birdhouse, Jordan uses 2 boards. One is 1/2 foot long, and the other is 1/4 foot long. What is the total length of the boards, right? I want to add them together. So, they did the models here, right? I have 1/4 plus 1/4. So if I have to add these two numbers together, 1/4 plus 1/4, where did I had a little piece of paper. Cover it. Sorry, never mind. Okay, so I'll use my finger. I'll use my pen. All right, so 1/2 plus 1/4, right? So I can break 1/2 into 2 pieces, right? If you remember how you could see them, and then I have 2 fourths. So here is my 1/2, right? And here's 1/4 and 1/4. It's the same size. So think about how many 6ths would I need, right? So this is when I make my number equivalent. These are all equivalent, right? They are all equal length, equal sizes. All right. So I'm adding this up. So now you see what they did. They took that and they made them into fourths. So now I have 1, 2, 3/4. Find fraction tiles that will match the length of the combined tiles. Line them up below the model. So that's what we did. Oops. I don't have more fourths because I only have one set of numbers. So I can't show you like how they did with, oh, I guess I could do it like that, right? I could put my 4th here, but I don't have enough fourths to put them down here below to show you like they did. If we were in class, we'd have 2 sets and we could match them up, but I didn't bring enough home with me. All right, so count. There are 3, right? 1, 2, 3 of the 1/4 fraction tiles in all. This represents the fraction 3/4. So 1/2 plus 1/4 equals 3/4. The total length of the boards is 3/4. Right? So that's all we're doing. I'm doing the same thing we kind of have been doing, adding my fractions, but now the denominators do not match. So 1/2 plus 1/4. Right? I could change my 2 into a 4. I could change a 4 into a 2 also. Right? I divide by 2. The only thing is I can't change 1. If I divide it by 2, I'll have 1/2 on top of 4. That's not a right? That's not a number. So instead, I'm going to change the 1/2. Right? When I don't know, I could write it over here so that you guys could, maybe that'll make more sense to you. Times 2 times 2. I usually write it on that side, huh? 1 times 2 equals, but then I'm doing my equals over here. So I could do it this way. 2 plus 1 equals 3. And 2 times 2 equals 4. Sorry. I messed up there, huh? Because I'm thinking 3/4 and I'm thinking ahead. Sorry, it's not 2 plus 1. See, this is why I shouldn't be using a pen. It's 2 times 1. Whatever I do to the bottom, I have to do to the top, right? I'm not even following my own rule. I tell you guys all the time. Whatever I do to the bottom, I have to do to the top. It's 2 times 1. 2 times 1 is 2. So I have 2/4. So now I'm going to change my problem. I'll have 2/4 plus 1/4 equals, now we did this last week, right, or all week we did this. 4, I don't add my denominators, right? I just go 4, 4, 4. But the top, my numerators, I do add. 2 plus 1 is 3. 3/4. Blech. Sorry, I need a drink of water.
Hi, miss you guys. Be good for teacher.
Alright, on to the back. Alright, Muna's family ate 2/3 of a strawberry pie. Yum. And Brendan's family ate 3/4 of a different strawberry pie. Right, there's 2 pies here. How much did they eat all together? Ooh, I thought they were going to, so right, they could ask me all kinds of different questions. How much was left of these pies, right? But they want to know how much they ate all together. How much did they eat all together? All right, so 2/3 plus 3/4. Right, this is what my, if I'm writing it down, will you guys write it down with me up here? Plus 3/4. We're getting practice, right? Equals. I do not have a common denominator, right? So that's what I got to figure out. What denominator is going to go there? And then I'll have to figure out what numerator, right? I'm going to have to change my numerators also. All right, so they did their little fraction strips here, right? 1/3 plus 1/3 plus 1/4, 1/4, 1/4, right? 2/3 plus 3/4. So how am I going to add these up here? All right, guys, so just so you can see here, I have 1 whole, right? This is more than a whole up here. So I have 1 whole right here. I have 1 whole is equal to 3/3, right? Which is equal to 4/4 and 12/12. I'm missing 2 of my 12ths here, right? This is why I always try and get everyone, put them all back in the bag, and look what I did. I lost 2 of them. Oops. So, anyway, but I wanted to show you this, right? This is up here. I have 1/3, right? I have 2/3, but I don't have enough to show you that, right? Stuff with all the 12s, because I don't even have enough 12s to show you 12/12s. So I have 1/3 and 1/4. So if you notice, my 1/3, oops, is equal to 4/12, and my 4th is equal to 3/12. And hopefully you guys remember your fun math fact, right? We're supposed to have these memorized. 3 times 4 equals what? Think about it, think about it. Say it out loud. I'm like Dora the Explorer. 3 plus 4 equals what? 12, you're right. Nice job. Alright, so looking at our fraction pieces over here, now I'm going to do my problem. I got to change this so they have a like denominator. I'm going to change this denominator right to 12. So now I got to think about this. To turn a 3 into a 12, I multiply it times 4. Whatever I do to the bottom, I have to do to the top. To turn my 4 into a 12, I need to multiply it times 3. Whatever I do to the bottom, I have to do to the top. Alright, so we're going to go down here with our book. So, find fraction tiles that will match up to the length of the combined tiles. Line them up below the model. If we were in class, we could have done that, right, and lined them up, but we're not. So now we'd have to count. There are blank of the 12 fraction tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 of the 1/12 fraction tiles in all. This represents fractions 7/12 or 17/12, right? This is an improper fraction. There's a bigger number in the numerator than there is in the denominator. So I have to fix this, right? To fix that, I'm going to take it. It's a division problem, right? 17 over 12 means 17 divided by 12. And when I want to do my little division stuff, I like to do these little houses. That's how I like to do them. You can do all different ways. If your parents have a different way, have them show you. You could even ask them, hey, Mom, how would you do this division problem? Hey, Dad, how would you do this division problem? How do you figure it out, right? This is my little work place that I work out my division. So 17 divided by 12. So 17, the first number is going to be the big one in a division problem. That's the one that goes inside. The bigger number gets to go inside. I can also divide by a smaller number, right? I could have 1/2. Then I have to use my decimals if I was turning from a fraction, right? Or you don't. You could still use a fraction, right? Anyway, sorry, I'd have 12, but it'd just be the same thing. Anyway, sorry. Okay, I'm going to keep going. So I'm going to have my divided by 12. My 12 goes out here. Can 12 go into 1? No. Can 12 go into 17? Yep. 1 time. 1 times 12 is 12. I subtract. 7 take away 2 is my 5. Right? If I was doing decimals, I'd put a point and a 0, and I'd keep going until I had no more decimals. But I don't. I'm not right doing decimals. I'm doing fractions. So it depends on what I would be using this for. So I'm going to say I have 1 and 5 over 12s. 5/12, that's as small as it can go. 5 can't get any smaller. It's just 1 times 5. 12 could go 3 times 4, 2 times 6, right? But neither of those are divisible by 5. So this is the best in its simplest terms, 1 and 5/12. And that's what they're going to tell you, 1 and 5/12. But let's figure out how they got this 17/12 over here, right? The 2/3 plus the 3/4. I started writing it out up here. So I'm going to go ahead and I'm going to write it again down right here. So will you write it with me down here? So we're going to write it one more time. I need 2/3 plus 3/4 equals something over 12. Right? I decided we're going to turn the denominator into a 12. We multiply times 4. Whatever I do to the bottom, I have to do to the top. We multiply by 3. Whatever I do to the bottom, I have to do to the top. So now I'm going to have 2 times 4 is 8. Plus 3 times 3 is 9. I'm going to move it over, right? I'm just carrying it over one more time. 12, that 5's in my way, sorry. 8 plus 9 is 17/12. Right, and I already did my math here, which is equal to 1 and 5/12. Right, there's 1 12 in 17. So then I subtract, I have 5, but I'm still dividing it up by 5. 5 divided by 12. Right, if I want to do this and I did 5 divided by 12, I'm like, oh, it goes in 0 times. 0 times 12 is 0. I subtract, I have 5, and I have 0 and 5/12, and I get rid of my 5. But what I was saying before, too, is right. We also, because I know we just did decimals, so don't forget your decimal places, right? So 12 goes into 5? No. I put a decimal and a 0. Does 12 go into 50? 24, 36, 48. So I'm going to do a 4. 48, right? Other than that, it'll be bigger than 50. So I'm going to do a 4. I bring up my decimal place right here. So 4 times 2 is 8. 4 times 1 is 4. I subtract. I can't subtract from 0, so I borrow. I get 10. Take away 8 is 2. Now I'm going to add another 0, right? I keep going until I'm out, until this equals nothing, or I see that I'm going to keep going forever, and then I just draw a line over it and stop at some point. So 12 cannot go into 2, so we bring down our 0. We added to the 0 already. We're bringing it down. Can 12 go into 20? Yes. 2 times? No. 2 times 20, 12 would be 24. That's too big. 1 time. So 1 times 2 is 2. 1 times 1 is 1. I subtract. I borrow again. I have an 8. All right, I'm going to run out of space here, though. So I'm going to do a 0. I'm trying to fit it in here. So I bring down my 0. Can 12 go into 80? Yes, right? I'd say, oh, 7 times 10, right? This is how I figured out. I'd probably go, oh, yeah, because 7 times the 1 will be 70. So, right, that's what I would do, but I'd be writing in pencil. I'd try 7. Let's try 7. 7 times 2 is 14. Carry my 1. 7 times 1 is 7 plus 1 is 8. Oh, but look, it's too big. I can't, right? This is where this time I cannot have negative numbers. So that's not going to work. So this is what I do my work in pencil, right? So I know 7's too big, so let's try a 6. So I'm going to say 6 times 2 is 12. Sorry, now I'm not keeping it nice and straight. It's just because I ran out of room. Sorry. I carry my 1. 6 times 2 is 12. Carry my 1. 6 times 1 is 6 plus 1 is 7. So 72, right? I'm borrowing here. So I need to borrow from my 8. Now I have 10. Now I have an 8. All right, right? And hopefully you guys could see, right, I'm going to do this again. Add another 0, bring down another 0. And I'm going to go another, oh, I just did that, right, to 80. I know it's going to be another 6. I'm going to keep, and then I could start, see, right, 6 times 2 is 12. I carry my 1. 6 times 1 is 6 plus 1 is 7, 72, 8. I'm stuck in a loop, right? This is just going to keep happening forever. So at some point, I'll stop, and I'm going to just draw a line over those numbers that keep repeating, and that's how I know it's still repeating. All right, if I lost you, just keep listening, because you're going to hear this someday, and then maybe you'll think back and be like, oh, I remember on the 5th grade computer with Miss Monserrati on the Zoom, she said something about repeating decimals. I'm even going to write it down. Or, I don't know, actually, I don't know all the 5th grade. Maybe we're going to talk about that, too, in a future chapter. So you'll remember when I say it again, when we do a future chapter. All right, so this is a repeating decimal. I'm going to write it on the back of my little card, right? I'm going to do 12, 5. I'll even write it like this. 5/12ths, which equals 5 divided by 12, which looks like this. Right, so I'm going to put I know it can't go in, I bring up my decimal place. Right, I'm just drawing myself a little map so I remember sometime. And we already did this, right? 4 times 2 is 8. I'm going to make it so pretty. 4 times 1 is 4 plus 1 is, 4 times 1 is nothing. Plus, I added nothing to it. I don't know. 4 times 2 is 8, and 4 times 1 is 4. I don't know. Anyway, I can't subtract from my 0, so I'm going to borrow from my 5. Now I can do this, right? 2, I add a 0, I bring it down. Now I'm going to go, how many times can 12 go into 20? Just one time, right? 1 times 2 is 2. 1 times 1 is 1. Subtract, right? 1 times 12 is 12. If I did 2 times 12, I'd have 24, which would be bigger than 20, and we cannot do that. I'm going to run out of room this time. Now this way. Man. All right, I can't subtract from a 0. I'll borrow 8. Add another 0. Bring it down. How many times can 12 go into 80? Right? We played around and found out it is 6 times. 6 times 2 is 12. Carry my 1. 6 times 1 is 6 plus 1 is 2. I subtract. Can't subtract from 0. I have to borrow 8. Right now I see my little thing. I'm going to keep doing this. Is going to be a loop forever. I'm going to just have another 6, right? I'll have an 80. I'll add another 0. 80. I'm going to just go 6, 6, 6. So instead, I'm just going to put a little line right over here. All right, and I like to use scratch paper too, right? A lot. So, oops. So I want to show you on here. I'm going to say, this is the same problem, right? I'm doing this, 5 divided by 12. So on my calculator, I'm going to say 5 divided by 12 equals 4166667. So hopefully you're like, wait, there's a 7, Miss Monserrati. How did they get the 7? Well, real easy, guys. Remember this. I'm going to keep doing this. The computer, right, the calculator is like, so the calculator is so smart. It knows at some point it's going to stop when it runs out of room. So I know my next number is going to be a 6 and a 6. And I know if the next number, and I want to round, right, if I round 66, at some point, sorry, I'd still do, it'd be, if I rounded 66, it'd be 70. Right, so at some point I'm going to just round those 66s and turn it to a 70. But I also know I don't need a 0 at the end. If I want to, I could put it, but I don't need to. Right, 66 rounds to 70. I look at the number to the right. I'm rounding to the tens place. I look to the number to the right. Right here, it's a 6. I go up to the next number here, 7. If it was 63, I look at right, and I'm rounding to the tens place. I look at the number to the right, it's a 3, it's smaller, so I'm going to stay a 6 and add a 0. So hopefully you remember rounding. Alright, so, right, that had nothing really to do with our problem that we're working on right now, but I do just like you guys to see these kinds of things, so, because I know you're going to see it again, but I'm also realizing I'm at 22 minutes. So from now on, I'm just going to go through the math. Alright, in the first activity, how does the denominator of the sum 3/4 compare to the denominators of the addends 1/2 and 3/4 and 1/4. So I have to remember what an addend is, right? An addend is the problem is the numbers I was just writing it on here. Oh, I have more little cards I could have written on there. An addend plus an addend equals a sum or a total. Right, so like this, a 3 plus a 4 equals 7. Right, and just to remember, a product times a product whoopsie, this is another thing when I write in pen. It's not a product times a product, right? It's a factor times a, I messed up. A factor times a factor equals a product, right? So remember, I'm finding the greatest common factor. I'm finding least common multiples. That's what I'm looking for. So right now, I found the least common multiple of these numbers, right? So I did 3/4. And so, sorry, and they were asking about activity 1, which we did over here on the other side. We compared halves and fourths. So how does the denominator compare to the denominators? So I am going to say, so these are the addends, right? And I was adding these two numbers together. I got my sum, my total. These were the numbers I'm adding together. There's one addend, there's another addend, there's my sum or my total. So they want to know about these two addends that we had. and there's my sum. How does it compare? So I'm going to say the denominator of the sum is the least common multiple of the addends. Those are the two numbers I'm adding together, my addends, right? And I could show you right here. I could do a little example of it. I'll do 2 and 4, and I'm going to do the multiples to find the least common multiple. So I'm going to do 2 is 2, 4, 6, 8. Right? Remember, I just like to do 4 of them, so I practice my multiplication facts while I'm doing this. I'm killing 2 birds with 1 stone. 4, 8, 12, 16. I'm going to see what number the least common multiple, right? The number that they have in common that is the smallest is the, I don't know, I think that's a Sharpie and not a highlighter. 4 and the 4, right? So that's why we used the 4 as our denominator here. All right, the next question, in the second activity, which was up here, how does the denominator of the sum 1 and 5/12 compare to the denominators of the addends 2/3 and 3/4, right? Very similar question. So I'm going to say the denominator and I'm going to fix how I spell denominator up here. I need an I-N right there. So I'm going to put a little caret telling you, I want you to put those two letters, I meant to put those 2 letters in there. Oopsie. The denominator of the sum is the least, I don't know why I'm capitalizing it now, common multiple. I do know why, but remember we wrote these in these little, right? This is my code. Once you see this, you'll be, oh yeah, LCM, I remember that. It's with fractions, or right when I'm trying to find the lowest common multiple to find the least common denominator, right? I'm finding the same kind of thing. I use it for different reasons depending on what I'm doing with my math, right? So here's my 3, here's my 4. I'm going to do them on top and so I can see them, 3 and 4. I'm going to count up to the 4th multiple. So I'm going to say 3, 6, 9, 12. Here I'm going to say 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? I'm just adding 4 plus. I'm adding 4, 4, 4, 4, 4. And those are my multiples. I see what is the least, the smallest, right? If I kept going, I could see there's going to be more numbers they have in common. But right now I see, I'm going to stop because I see a 12 and a 12. It's the smallest number that they have in common. All right, next one. Use the answers from exercise 1 and 2 to predict the denominator of the sum 1/3 and 1/4. All right, so we did this. So if it had a denominator of 3 and 4, I'm going to say the denominator, right? They're not asking me to do this problem at all. They just want to know the denominator will be, oops, I forgot my I, will be 12. Because, my beautiful word, because it's spelled right, C-A-U-S-E. It's a funky spelling. Because 12 is the, let's put our little abbreviation, right? That's why they do it, because math people are lazy with words. They just want to do numbers. They don't want to write out words. Is the LCM of the lowest common multiple of 3 and 4. Period. The end. I just did it right here, so I could like go see over there. All right. If you need to pause it and finish, then you do that. I'm going to keep going because otherwise my video is going to be 8 years long. All right, so here is my next problem. Find the sum using fraction tiles. Write in simplest form. Draw the models. I was filming that whole time. Sorry, I was looking for my numbers. Now it's going to be the super longest video. Sorry, oops. Okay, so I would start recording again, but then I have to start recording again. All right, so 2/3 plus 1/6. Right, that's what I'm trying to do. I don't have enough sixths, so I could do this, so I could show you. Oh, I do. Sorry, I do. Yay. All right, so we'll see. 2/3 plus 1/6 is going to be equal to 1, 2, 3, 4, 5 sixths. Right, and since if you guys don't carry these around with you in your pocket, right, we're going to do these using real math. So I'm going to say 2/3 plus 1/6 equals, I know my denominator is going to be 6. So I'm going to change this denominator into a 6. To do that, I'm going to say 3 times 2. Whatever I do to the bottom, I have to do to the top. So I'm going to say 2 times 2 is 4. And 3 times 2 is 6. So 4/6 plus 1/6, 4 plus 1 is 5. All right, so now I'm going to do these without my fraction tiles. Just kidding. I'll show you with fraction tiles. So I have 3/8 plus 1/4, right? That's what I'm trying to do. 3/8 plus 1/4. Oops. So I actually even have an extra 8 in this bag, so 2, 3, 4, 5, right? 1, 2, 3, 4, 5, same length. So I'm going to have 3/8 plus 1/4 equals 5/8. And we're going to do our math for it also, right? 1/4 is going to be equal to, I'm going to do this times 2 and this times 2. So instead, I'm going to have 4 times 2 is 8, 1 times 2 is 2. Maybe I would like cross this out. So now I know I'm adding this to this now. So 3 plus 2 is 5. Denominator is 8. All right, so now I have 1/5 plus 3/10. 1/5 plus 3/10. So I'm going to take my tenths and figure out how I can have this be all tenths instead of that fifth in there. The fifth throws me off. I can't write it like that. My word's longer. My problem's longer. So I'm going to see how many tenths here match up, right? So I'm going to say 1, 2, 3, 4, 5. I have too many tenths in this package, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But that works. So I'm going to say this is going to be equal to 5 tenths. But remember, I have to do in my simplest form, right? 5/10 is going to be equal to, right now I'm going to do my greatest common factoring here, right? 5 has 1 5 in it. 10 also has a 5 in it. It actually has 2. So I'm going to divide by 5 on the top and divide by 5 on the bottom. On the top I'll have 1 5. On the bottom I have 2 5s. So this is equal to 1 half. Alright, so instead of all the little fraction tiles, no, never mind. Alright, so here now I have 1/4 plus 5/8, right? It's written like that. 5/8 plus 1/4. So I could see that this 4th is going to be equal to 2/8. So I'm going to say I have 1, 2, 3, 4, 5, 6, 7 eighths. But I'm also going to do it with math, with numbers, right? So 5/8 plus 1/4. So my 1/4, I'm going to multiply this times 2 times 2. This is going to be equal to 2/8. So now I'm going to add 5/8 to my 2/8. Right? The denominator stays the same. The numerator, 5 plus 2, 7/8. It's in the simplest form. I can't make it any smaller. Alright, so 1/3 plus 1/4. So 1/3 plus 1/4. Remember we did this. We did 2/3 plus 3/4. Now I just have one of each, right? So 1/3 plus 1/4. I'm going to go for my 12ths. I have 1, 2, 3, 4, 5, 6, 7. I wonder if you guys notice what 3 plus 4 is. 7, right? Because it's just the unit fraction. Right, the unit fraction is 1 over anything. I always make an A down here, but I'm going to put an X this time. 1 over anything is my unit fraction. So I want to change them both into 12s. So I'm going to just move my whole problem over this time. Equals, so I'm going to say 1/3, I'm going to multiply the bottom times 4 and the top times 4. Here I'm going to multiply the top times 3 and the bottom times 3. 3 times 4 is 12. 4 times 4 is, 4 times 1 is 4. 4 times 3 is 12. 1 times 3 is 3. So now I have 12, 12, 12. 4 plus 3 is 7. Alright, one last over here. 3/4 plus 1/6. Alright, so I am looking for my least common multiple, and I could get out all my little models, and that is what we would do if we're in class, but we'd probably run out of time there too, and I'd make you do it this way. So I'm going to take my 4 and my 6. I'm going to find the multiples. So 4 is 4, 5, 6, 7, 8. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. Hopefully you guys can see, right? I got to go a little more here. I can't stop at 16. 16 plus 4 is 20. And 20 plus 4 is 24. Here I'll be fine if I just do 4 multiples of 6. 6, 12 plus 6, 18 plus 6, 24. And now I have my least common multiple of 4 and 6 is 24. So I am going to put a 24 on the bottom of my problem here. I'm like thinking how I should do this. I lost my white out, so I don't know what happened to it. So I'll do it up here, and I'll write my final answer down. No, I'm going to write my final answer. Alright, I'm going to keep going. I'm going to do plus in here. I'll put 2 fractions right there. So you guys hopefully can see. I multiply my bottom times 6, so I multiply my top times 6. I multiply my bottom times 4, so I multiply my top times 4, right? 1, 2, 3, 4, 5, the 6th plate, right? 1, 2, 3, 4. Alright, so now I'm going to say 4 times 6 is 24, and 3 times 6 is 18. 6 times 4 is 24, and 1 times 4 is 4. So hopefully you guys see why I couldn't use my little fraction tiles right now. I don't have 24 of them. Alright, so if we were in class though, we would, but still, that's a lot. So I'm going to say 24, 24, 24. 18 plus 4, 22. So I have 22 over 24. But now I have to see how, I can't leave them, right? I can see right here, I can divide a 2 into them. So now instead of that, finding my least common multiple, I'm going to find my greatest common factor of 22 and 24 so I can find my simplest form, right? I know this is a little tricky, guys, but I know you guys can do it. So 22 and 24. I'm going to write it up here. So I'm going to say 1 and 22. I didn't need to write them that far apart, huh? 2 and 11. Right, will 3 go into that? No. 4, no. 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. Right, nothing else will go into 22. 1, 2, 11, and 22. How about 24? 1 and 24. Right, 2 and 12. 3 times 8 is 24. 4 times 6 is 24. 5, no. So now I have to find out what is the greatest common factor here. So hopefully you can see here it is going to be 2. And maybe you like doing the trees, right? This is your favorite way. You don't like this way. You want to do it this way. I'm going to say 22 is 2 times 11. And then I stop because 2 can't get smaller. 11 can't get smaller. Over here, I'm going to say 2 times 12. 12 can get smaller. It can be 2 times 6. Ooh, 6 can get smaller. It can be 2 times 3. They both just have a 2 in common. And I don't use both 2's and multiply them by each other and get a 4. Not for this way, right? Not that that's something different. So I'm just trying to find my greatest common factor. I know it's a 2. So I'm going to divide my top by 2, and whatever I do to the top, I have to do to the bottom. 22 divided by 2 is 11. 24 divided by 2 is 12. So final answer, 11/12. And hopefully you guys could see 11/12 is very close to 1. It's almost a complete, I only have 10/12, so I can't even show you. All right, on to the back. Alana walks east 4/9 of a mile to school every morning. On Saturday, she walked to a friend's house, which is 1/3 mile farther east from her school. How far did Alana walk to her friend's house on Saturday? Right? She told me that she walks this far to go to school every morning. Well, it was a Saturday. She doesn't have school. So instead, she's going to go to her friend's house. It's a little bit farther than the school, right? So here's Alana. Here's the girl's house. Here's Alana. Here's her school. Here's her friend's house. So normally to go here, it's 4/9 of a mile. I didn't draw this very good in proportion. But this time she's going to go this way. Right? This is 4/9 of a mile. And this girl, when she walks to school, or boy, they only go 1/3 of a mile. So I'm just going to add those two together. So I am going to do it right here. I'm going to say 4/9 plus 1/3. I'll change my third into something. Equals, so I'm going to change my 3, into a 9. Which is easy, right? I could change my 9 into a 3, right? I could divide by 3, but 4 divided by 3 does not work. So I can't do that. So instead I'll do it this way. 3 times 3, whatever I do to the bottom, I have to do to the top. 1 times 3 is 3, 3 times 3 is 9. Right, so now I'm just using 4/9 plus 3/9. 9, 9, 9. 4 plus 3 is 7. So I'm going to say 7/9 of a mile. Oh my goodness, it's getting very long. Mr. Hawkins gets 2 bonus payments every year. This year, his first bonus payment was 1/4 of his salary. His second bonus was 1/8 of his salary. What was the fraction of his salary for his combined bonus payments? So, right, you picture this guy gets a paycheck, and then once in a while, twice a year, he gets a bonus, or he gets 2 bonus payments every year. Yeah, so twice a year he gets a bonus. So one of his bonuses is 1/4. One of his bonuses is 1/8. Hopefully you could see that even though this has an 8 on the bottom, this one's going to be bigger, right? So let's say he makes $40, right? One of his payments was going to be $10. The other one's only going to be $5. One of his bonuses. All right. So what fraction of his salary what was the fraction of his salary for his combined bonus payments? I'm going to do 1/4 plus 1/8. So I'm going to change my 4 into an 8 by multiplying it times 2, multiplying it times 2. 2 times 1 is 2. 4 times 2 is 8. Right, so now I'm going to add 2 8s plus 1 8. I had to change my number before I add it. 8, 8, 8 on the bottom. 2 plus 1 is 3. So I'm going to say 3/8 of his salary was his combined bonus payments. So he made $15 for both of them, right? Because they could ask me all kinds of questions. At a gas station, but they'd have to tell me how much he made here to figure that out. We just made up a $10 amount of $40. He'd get a $10 and a $5 bonus. At a gas station, Kurt asked for directions to the nearest town. The attendant told him to go 5/6 of a mile south and then 1/4 mile east. How far does Kurt have to drive to get to the town? So I'm going to change my 5/6 and my 1/4. All right, so 5/6, right? I need to make these a common denominator. 6 and 4, what do they have in common? Right, we already did this, so I'm going to just refer back to my 4 and my 6 here. Their common denominator is 24. So I'm going to say my denominator is going to have to be 24. So to turn my 6 into a 24, I say 4 times 6 is 24. So whatever I do to the bottom, I have to do the top, which is going to give me 4 times 5, which is 20, and 4 times 6 is 24. So now I'm getting rid of these numbers, crossing them out, because I'm not using these numbers, 20 over 24. I have to change my 1/4 also into a 24 denominator. So I'm going to say equals times 6 times 6. 1 times 6 is 6. 4 times 6 is 24. So there we go. 24, 24, 24. 20 plus 6 is 26. Hopefully you guys see we can't do that. Right? Your red light should be going on right now. Going, wait, the numerator is bigger than the denominator. That does not work. It's an improper fraction. We need to fix it. All right, so how are we going to fix it? We're going to divide. We're going to say, I could also do it a different way. I could say, this would be, let's do it a different way. I'm going to say 24, right? I know, this would be also a 24. This is going to be 1, right? This is going to turn into a 1. And I know to get 26, 24, I'd have to add 2, right? 24 plus 2 would be 26, so that would work. So now I'm going to say my answer is going to be 1. I'm going to turn this into a 1. And 2 24ths. Hopefully your alarm's going off again. It's not in its lowest terms, right? I can divide this by 2 and I can divide this by 2. So this is going to be equal to 1. I'm going to divide by 2 and divide by 2. 2 divided by 2 is 1. 24 divided by 2 is 12. Oh, and I have a unit fraction. 1 and 1/12. All right, next one. It says, write a real-world Write a real-world problem that can be solved by adding unlike fractions. All right, so I'm going to talk about paths. One path, I'm walking on a path. I'm copying your book, sorry. One path is, sometimes I don't like their examples, but I could picture you guys, right? You're walking on a path. It's 1/12 of a mile. And I'll just put a period. Another path is 1/4 of a mile. Right, I say of, it doesn't say that there, but that, so I can't say 1/4 mile, it just sounds funny. Another path is 1/4 of a mile. What is the total length of the two paths? Question mark. I start my sentence with the capital and I end it with punctuation, which in this case happens to be a question mark. I'm going to add 1/12 plus 1/4. I'm going to solve it for them, right? It didn't ask me to solve it. It just said write a real-world problem that can be solved by adding unlike fractions. 1/12 plus 1/4, but it doesn't say and then solve it. So I really probably don't have to, but they did in the book. Plus, and it's good practice for you, right? I'm going to say 12, because this one I'm going to have to change it up and change it back. Sorry, so 4, I can turn 4 into 12. I'll multiply it by 3. Whatever I do to the bottom, I have to do to the top. 1 times 3 is 3. 4 times 3 is 12. Now I'm going to add this 1/12 to this 3/12. 3 plus 1 is 4. 12, 12, 12. But hopefully you guys see, oh, they have common multiple here, right? I'll do it with a little tree. I can do it right here. I'm getting better at this little tree. 2 times 2. Right, over here we have 2 times 6, which is 2 times 3. Oh, this problem has 2 2's, and this problem has 2 2's. Oh, and 2 times 2 is 4, right? I don't use both of them. I'm going to say 2 times 2 is 4. So I'm going to divide by 4. I'm going to divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. How can I use models to add fractions? I can use models to find equivalent, sorry, that's a cute, fractions. I should be writing in cursive, huh? Talking to myself. I can use models to find equivalent fractions, or you could answer me. It'd make me feel better if you're answering me. Tell me later. I answer you in your video, Miss Monserrati. Alright, so find the sum of 2/3. We're on to the homework. Maybe that's what I'll do. I'm going to pause and I will do the homework on a separate video.